We've already discussed probability with one event. So a probability in one event, you end up with one fraction. It's either you're selecting one thing or you're selecting one of two things, so like a blue or a red. So we also have a situation where we're going to be finding the probability of two or more events. And so if we're looking for two or more events, that's indicated by the word and, because if you're looking for a red and a blue, or a heads and a tails, that's two events. That's different from or in that with the probability here with 4 or 2, it doesn't matter which of the two you get, you want to get one of the two. So this is a one event. But the word and indicates that it's going to be two or more. So just remember that over here, this is going to include the word and in it. And means more than one. So two or more events can be either an independent event or it could be a dependent event. And so the difference between these two is, just like if your parents are moving to Alaska and you're still living with them, you're a dependent. If they move to Alaska, your life is affected. You also are moving to Alaska. But if you're old enough and then you move out of the apartment, if you move out of your house and you're living in your own apartment, you're now an independent person. You no longer live with them. So if your parents move to Alaska, it doesn't matter. You don't have to move to Alaska just because they moved to Alaska. And so that's the difference. It's when you're independent and out on your own, where your parents move doesn't affect you. And with your dependent event, so long as you're a dependent living in their household, if they move to Alaska, guess what? Pack up something warm because you're going to end up going to Alaska too. So it's the same thing with these events here, and I'm just going to just read these two, and then we're just going to focus on independent. So the outcome on an independent event, remember, independent is like if you're out on your own and wherever your parents move, you don't have to move there. It says the outcome of one event blank influence the occurrence of the other event. So does the outcome of one event influence or not influence? Well, this is the one where it does not influence. So the outcome of one event does not influence the occurrence of the other event. So it does not influence the occurrence of the other event. So the second event occurs regardless of whether or not the first occurs. So your parents are going to move whether or not you move when you're an independent person. On dependent event, if the outcome of one event blank influence the outcome of the other. This one does influence, so the outcome of one event does influence the outcome of the other. So if your parents move, you have to move with them. The second event is considered only after the first event has occurred. So if your friends ask, are you moving to Alaska? Well, you first have to see, are your parents moving to Alaska? So if your parents are moving to Alaska, you're moving to Alaska here. So the second event is considered only if the first event has already occurred. So let's go ahead and focus on independent event since we've got that out of the way. For example of an independent event, again remember independent event is one does not influence the other. It says, for example, the first roll of a number cube does not influence the second roll of another of the second roll of the number cube. So for example, so the first time you roll a number cube, you have 6 sides. So here I rolled a 5. The second time I go to roll this number cube, the number cube doesn't change. There's still 6 sides. So it doesn't matter every time I roll this, it's going to be independent because this cube never ever changes. Other examples are flipping 2 coins. So if you flip a coin the first time, you can either land on heads or you can land on tails. And the second time you go to flip it, you can still land on heads or tails. And that's different. Let me just show you a really quick example about what it is to be different. Here you have a bag of blue marbles, red marbles, and yellow marbles. So let's just say if I pick out of this bag and there's 10 marbles, and I pick one out and I keep it, then the second time there's not 10 marbles anymore, now there's only 9 marbles, so it does change. So on dependent event, the numbers are going to change, because then if the third person then goes to pick it, then there's no longer 9 marbles, now there's 8 marbles. So every single time somebody takes a marble out, the numbers in the bag change. So this is dependent, where independent, no matter how 500 people can roll this and it doesn't change. They're all going to have the same possibility of getting any of the 6 sides. So let's see here. So rolling a number cube, flipping a coin, selecting a card, and choosing a card from a deck, then replacing the card. So again, if you have a deck of cards and there's 52 cards, if you pull one out, look at it, then put it back, then the next person who chooses is going to have the same probability that you did. There's 52 cards, and then they put it back, and then the third person pulls one. There's still 52 cards because everybody's putting it back. Unlike dependent, where the first person pulls it out, there's 52, then they keep it, then the second person pulls it out, then there's 51, and then the third person pulls it out, and then there's only 50. So that's dependent. So an independent event, everything is exactly the same no matter how many times things are pulled or rolled or flipped or anything. So just remember that this word replacing goes with independent, because independent means it's going to be the exact same. Everybody's putting everything back. So let's try this one. The probability of, what is the probability of 3 events? What is the probability of 3 independent events is found by using the following formula. So here's your formula right here for independent events. What is the probability of A and, there's that word and, B and C is equal to the probability of A times the probability of B times the probability of C. So remember, you're going to multiply. You're going to get your 3 fractions and you're going to multiply all 3 of them. So here's an example. When rolling 3 number cubes simultaneously, that means at the same time, what is the probability of rolling a 3 on one cube, a 4 on one cube, and a 5 on the third cube? So these are independent because all of these are going to have the same 6 sides. So what is the probability? First we have to write down a fraction for each one of these. So what is the probability of rolling a 3? What is the probability of rolling a 4? And what is the probability of rolling a 5? So what is the probability? We're going to look at each one of them separately. There's only one 3 on this cube, so there's a 1 in 6 chance because there's 6 sides. So there's a 1 in 6 chance of rolling a 3. There's a 1 in 6 chance of rolling a 4 because there's only one 4 on this number cube. And there's a 1 in 6 chance of rolling a 5 because there's only one number 5 on there. So what we're going to do is we're going to multiply all 3 of these fractions together. So 1/6 times 1/6 times 1/6, or if you want to put them in parentheses, it's up to you, however it is that you want to multiply these. So when you multiply fractions, as a quick refresher, you're going to multiply the numerators and then you're going to multiply the denominators. So 1 times 1 times 1 is 1. Then 6 times 6 times 6. Let me get a calculator. 6 times 6 is 36, and 36 times 6 is 216. So you have a 1 in 216 chance of rolling your dice and getting a 3 on one of them, a 4 on another one, and a 5 on the third one. So converting this to a decimal, that would be 0.004. And then converting this to a percent, well, if you move your decimal 2 places to the right, you have, it's a 0% chance that you're even going to do this. It's less than, it's a 0.4% chance. It's less than 1% chance that if you have 3 cubes and you roll them, that one of them's going to land on a 3, another one's going to land on a 4, and another one's going to land on a 5. So someone says, I'll give you $1,000, or you give me $1,000. This is the horrible thing about gambling. Depending, if you give them $1,000 and they say, if you roll these 3, it doesn't seem like it's going to be that hard, but you have not even a 1% chance of this happening. And so if you look at this on the likelihood scale, it's like it's as close to 0 as 0 could possibly get. I mean, it is so close that it's close to impossible. It's not impossible, but it's close to impossible. So I'm just going to say very unlikely. It's very unlikely that that's going to happen. And so for our second example here, flipping a coin 3 times, we're going to flip the coin 3 times and landing on tails, heads, and then tails. So what is the probability of it landing on heads, tails, and then tails? So heads, tails, and then tails. So looking at each one of these individually, so if you have this coin here, What's the probability of it landing on heads? There's a 1 in 2 chance, so this is this one. There's a 1 in 2 chance of it landing on heads because there's 1 heads out of 2 sides. Times, what is the probability of it landing on tails? I'm going to say put an and right here. I should have put an and. Then tails, there's 1 tails out of 2 sides, so there's a 1 in 2 chance of this one. And then again, what is the probability of tails? There's a 1 in 2 chance that you're going to land on tails also. So now we're going to multiply these 3 together. So 1 times 1 times 1 is 1. 2 times 2 is 4, and 4 times 2 is 8. So you have a 1 in 8 chance of flipping a coin 3 times and getting a heads the first time, a tails the second time, a tails the third time. So converting this to a decimal, you have 1 divided by 8, which is 0.125. So this is equal to 0.125. Changing this to a percent, you have a 12.5% chance of flipping a coin 3 times. And so with your 3 cubes, here was your chance here. So a 12.5% is about right here. You have a better chance of that happening, but look at how unlikely it is that it's going to happen. So I'm going to say that this is unlikely. So it's unlikely that that's going to happen as well.